Like, share, and subscribe. Hello everyone, welcome back to my channel. Overall good at educating. So today we'll be going to learn about the first chapter in science, that is in 9th standard, matter in our surrounding. Okay, everyone know what is a matter. From many previous years or previous classes you are learning about the matter. What is a matter? A matter is something which is occupying space and has some weight. Okay, so you would have seen many things surrounding you. We have plants like trees, we have like house, and some other examples we have like book, pen, a dog, a man, which is in your paper that is given below. So these are some examples. A book is occupying so much of space, and when you take up it has some weight. Even the pencil is also the same. The dog is a living thing. Even the man is also a living being. So here even a man occupies some space and it is having some weight. So all these comes under the matter. So this is about the physical nature of the matter. Nature of the matter, the meaning of a matter is, or a definition is, as objects which has mass and can occupy certain space is called as what? Matter. Hope you have understood about the matter. Everything surrounding us is a matter. So next we have the physical nature of a matter. What is the physical nature? Like the first point we have, the matter is made up of millions of tiny particles. How the matter is made up of? Matter is made up of through a millions of tiny particles. The particles of one type of matter is different from the particles of the another type of a matter. Like you can see the previous examples, we have one pencil and a man. A man is separately, it is all having all the living components in it, whereas a pencil is having the non-living component in it. Okay, so like that, similarly the particles are also different from one type of a matter to the other type of a matter. So there is one small tip given here. What is it? Is smell in an abstract concept and not matter, but smell of any substances in matter is in as in gaseous forms of substances which has mass and can occupy space. So what is smell is an abstract concept. What it is? A smell is an abstract. You know what is an abstract? Abstract is something which we cannot see, we can just imagine. Okay, we can smell it, that's it, but we cannot see it concrete. It's not an concrete, it's only an abstract. But all concrete objects all comes under matter is something which is occupying space and can has weight, whereas the smell is nothing like that. It is not having the space also, it is not occupying the space also, it is not having the weight also. The next important part is characteristics of a particles of matter. That is, which are the particles, what are the characteristics we have for the particle of matter. First point, the particles of matters have space between them. So what is the first point? The particles are having space between them. Example, we have the formation of sugar solution. When we make sugar solution, the particles of one type of matter get into the space between the particles of the other. This shows that there is enough space between the particles of matter. Like example, you take up the sugar and add into a glass of water. Then what happens? The sugar start dissolving in the water. Okay, that means the sugar particles are going and attaching to the water particles. Okay, this means that both the particles of the matters are having the space between them. If there is a space, then only they can merge with each other. Then second point, the particles of matters are continuously moving. Like example, you can see mixing of ink in water. That is, when we are adding one drop or two drops of ink in the water, what happens? The particles of matters are continuously moving and they possess kinetic energy. You know what is a kinetic energy? Kinetic energy is nothing but the energy which tends to flow. The flowing energy is called as what? Kinetic energy. As the temperature rises up, particles move faster. This means that with an increase in temperature, kinetic energy of the particles also increases. You know that sugar will dissolve very faster in hot water than in the cold water, because in hot water the temperature is rise, so the kinetic energy is also rising up. Okay, so we can tell that if there is a hot water, the sugar will dissolve very faster when compared to the cold water. The third point is the particles of matter attract each other, means both the particles of the matter, if we are taking two matters, what will happen here? Both the particles are attracting each other. Okay, example, we have chalk has a rigid structure. So what type of structure it is having? Rigid structure, it is not flexible. Okay, this is about the three characteristics of a particles of matter, that is, it is having some space between them. Okay, particles are of matter having space between them, particles of matter are continuously moving, and last is particles attracting each other. Some examples are given here, like ink and the sugar solutions. So you can see here
2,000 years later.
the ink is completely turning and dissolving here, to give an examples that the particles are having space and can occupy some space. Okay, so examples, we have one question we have here, like a driver is able to cut through a water in swimming pool. Which property of matter does this absorb? So we can tell that it is having some space between them and have weak intermolecular forces of attraction between them. So what type of forces they are having? They are having weak intermolecular. Inside the molecules, the forces is very weak. So we can find the space between them. Okay. So what happens here? A driver can cut off through the water in the swimming pool. Next, we have states of matter. We have totally 8 states of matter, but it's not mentioned properly anywhere. But we considered 4 as the main states of matter. In that also, the fourth state is not much considered. Only these 3 states are considered, that is solid, liquid, and gas. There is plasma state. Plasma state is not much considered as one of the states of matter. As you go for the higher studies, you will get to know about the plasma state also. So let us learn in detail about solid. What is solid? How it is? The particles of solid are very close to each other. You can see a brick. A brick, how it is? Wood, a brick, or a wall which is built. Okay, what is there here? Particles are very close to each other. They have negligible space between them and they vibrate at their place. So what important properties of solids are? The first is particles of a solid have a strong intermolecular forces of attraction between them. That is, they are having very strong molecular attraction between them. Okay, and internally those one molecules are attached to it with a very strong force. Okay, the second, they have a fixed shape and a volume. They are having a fixed shape and volume. They cannot take the shape of the container. The solids have a rigid structure. The solids are incompressible. See here, the points I will explain you. First point is they are strong intermolecular forces. Like you take up the brick, we can take up any wood, we can take brick, we can take, and other examples we can take. Mm, like any solid materials. Okay, if you take up, you cannot break them because they are having. If you break them, they will equally divide. Okay, it is not that they will go into the small pieces. They can break, but still what they are connected each other with the intermolecular forces. Second is they are fixed shape. You can see any building or any wood or anything which is very hard in substances, they are having a fixed shape. They cannot take the shape of the container. Like you have a box and duster in the class, the window, everything is what it is having fixed shape, and also the volume. Next, we have the solid will not take up the shape of the container. Unlike the liquid, any water, if we take whichever the shape the water will take that shape, but not with the solid. Solid doesn't take any shape of the container. Okay, it is having its unique shape. The solids have a rigid structure, that is, they are not flexible, they cannot be bent. Okay, like we have bark of the tree, if you bend it, what will happen? It will break. Okay, whatever the solid things, what we does, we try to bend it, but what will happen? If we bend, they will break into pieces. So that property is called as what? Rigid property. Solids are incompressible, we cannot compress. Like in the gases, we can compress the gas and we can transfer it into a liquid. It is not with the solid. So we have some special cases where we can find this. So example, we have a sponge come under solid, but what will happen? There will be a small tiny holes in the sponge that makes the air to come out when it is pressed or expelled out, that is, air will be removed out. Okay, Even again it goes back and becomes the solid. The second special case is about the rubber band. See, rubber band can change its shape by stretching and can regain after removing forces. So this is also an example of a solid, but due to some uh, what we are adding some pressure. We are bending it. Okay, and again, if you remove the forces, what will happen? It comes back to its normal position. So the third is when you rotate this hourglass, that is the glass which contains the sand. So we used to make the studies or time or fixing a time, we use that, right? So in that, what happened, it looks like the liquid is flowing, but it's not the liquid, it is the solid particles, okay, or the solid sand particles which is isolated, okay. And you will find that each particle has fixed shape. So there is a large amount of sand is poured, it will look like it's flowing, it look like flowing, but it's not in the liquid shape. It is always considered to be the example for the solid, okay. These are the three special cases where the solid also one is getting compressed, that is the sponge what we are using, it gets compressed and regains back, okay, to its position. Similarly, the rubber band also, once it is force is applied, it will stretch and again it will regain. And the third example is hourglass. When we rotate the hourglass, both the position, what will happen? It looks like a liquid, but already the particles are in the solid state. This is about the solid. So next learn about the liquid. See, the liquid particles of the liquid are slightly far from each other. So how the particles are? They are slightly far from each other. So the force of attraction between the particles are not strong as particles can move freely. So there is no force of attraction is very less. With the force of attraction is very less, they are not strong enough. So what will happen, the particles can move freely, okay. They have a little space between them. So this gives us the most important properties of liquid, which are as follows. So these two properties are important, and we have some other important properties which we will going to learn here. The particles of liquid have a intermediate intermolecular forces of attraction, that is they are having intermediate intermolecular, that is inside the molecules what we are having, the force of attraction is there, but it's not much as in the solid state. Liquid have no fixed shape but they have fixed volume. Means whatever the shape it is, a bottle, you can have hundreds or thousands of shapes of a bottle, but what happens, the water will the liquid will take the shape of the container, but it is not having a fixed volume like we have in the solid, we don't have in the liquid. Liquid can take the shape of the container. Already you know this. Whatever the shape of the bottle you have, it takes that container or that shape itself, okay. Liquid has no rigid structure. It can be bent, like water can be bent, like whatever shape it is we can take up. It is very flexible, it is no rigid structure. So liquids are incompressible. Here one more point here, like solids also we have, the liquids also are incompressible, but in some certain cases we can find the solid, like we had the sponge, then we had rubber bands, and then we had hourglass. These were the three from which even they were having the solid property, though they were in the different forms. One more important property is the last property, the liquid can flow easily. We can see that the liquid can flow easily. These are the important points of the liquid. So we have one more question regarding the liquid. Liquid generally have low density as compared to solid, but you must have observed that ice floats on water. Find it out while. The answer here is the ice is solid, okay, but it has low density than water. Because of the cage-like structure of ice, it has lot of space between them, so it floats on water. We can say that because of the density. The main answer you can get here is the density. The ice is having less density when compared to water. Ice floats on the water, okay. And because of his one more point is cage like structure of ice, okay. Because of the cage like structure, what is happening, the lot of space between them is present, so it will float on water. The next we learn about the gases. The particles of the gas are very far from each other, so for the force of attraction between the particles are weak and the particles can move freely in all the directions. They have lot of space between them, so that because of these we have certain properties as they are having a lot of space between them. The first point is the particles of gas have a weak intermolecular force of attraction between them. So why it is having the weak intermolecular forces? Because there is lot of space between them, so there is a weak intermolecular forces of attraction between the gaseous, okay, gases. The gas has neither a fixed shape nor a fixed volume. We don't have a fixed shape and nor a fixed volume. The gas can take the shape of container. What the gas can take? It can take the shape of any container in which it is filled, okay. The gas has no rigid structure. It is not flexible, it is not rigid also. Like if it fills in the balloon, it is flexible. We can make the balloon to move from one place to another place. The gas is compressible. See, this point is very very important. Solid is incompressible, liquid is incompressible, whereas gas is compressible, okay. You know that the gas cylinders what we are using at home, okay, that is all the liquid LPG, that is liquefied petroleum gas. That gas is compressed and changed into the liquid form, okay. The gas can flow easily. What the next fourth, fifth point we have is, sixth point is the gas can flow easily. These are the very very important points of the gas we have. That is, they are having weak intermolecular forces. Second point is they are neither having a fixed shape nor fixed volume. They can take the shape of the container. It is not having any rigid structure. It is compressible and gas can flow easily. These are some important points of the gases. So you can see in this pictures how the solid and liquid and gases are, okay. So in this box we can see that we can get a very good information here in all those points in one box. That is, intermolecular force of attraction is strong in solid. In liquid, it's not strong, and even in the gas also it's not strong. And then fixed shape. A solid is having a fixed shape, whereas liquid has takes the shape of the container. Whereas gas are free moving, they don't have any shapes, they don't have any volume. But the point is that the solid cannot take the shape of the container, because already there is having a shape. The liquid can take up that, and even gas can take up that. Rigidity. The solid is having the rigidity, whereas liquid and gas don't have rigidity. Compressible. Solid is incompressible, liquid is incompressible, whereas gas is compressible. Fluidity. Solid is 0 at the fluidity, liquid can have, and even gas can have this properties, okay. From these boxes, if you understand this one box, then you can easily write down what are the different characteristics of a solid, liquid and gases. Next important point is diffusion. What is diffusion? The process of intermixing of particles of two different types of matter is called diffusion. What we are doing here, we are mixing it internally, we are mixing in the two different types of matters in one to make this is called as what? Diffusion. The order of the rate of diffusion in different states of matter is, first we have highest is gas, and then liquid, and then solid. The rate of diffusion increases with the increase in temperature. As the temperature increases, even the diffusion rate also increases. Why it increases? Because when the increase in the temperature, the kinetic energy of the particle increases when they mix into another quickly. As I said you in the previous this one, that sugar will dissolve very faster in the hot water, whereas in the cold water it will not dissolve. The reason here is, it will dissolve but it will take a lot of time. The reason here is because if the temperature is rises, kinetic energy also will rise. This makes the sugar to dissolve faster in the hot water, okay. One question we have here: arrange the following substances in increasing of the forces of attraction between the particles, like water, sugar and oxygen. Solution for this is, the force of attraction is strong in solid and weak in gas. Sugar is solid, water is liquid and oxygen is gas. So the order of the forces of the attraction between the particle is oxygen, then water, then sugar. So from this you can understand that increasing of that is what type of forces of attraction is there. Based on this those concept we can answer this question, okay. You can see the picture here where the dye molecule is dyes are getting mixed with the water molecules. So this is one example about the diffusion, how these two different matters are mixing together. Next important is, can matter change its state? That is, can we change the solid from liquid or liquid from gas? Yes, we can change. Like solid, we have example, we have ice cubes. When it starts melting, it will become water. Okay. And again, those melting, when we are heating it, it will change into water vapor. Okay. Melting melting, then warming, and then evaporating. And again, that evaporation, once we are condensing, it will change to the cooling and becomes water. And again, those cooling with a 0 degree freezing, it will become the solid. Okay, in this way we can interchange from solid to liquid, liquid to gas, and again gas to liquid and liquid to solid. In this way we can change the states of the matter. Okay, so here melting from ice from 0 degree to 100 degree Celsius, it will change. Okay, and then again from 100 to 0 degree is called as what? Freezing. Everyone know there are three states of matter, and these states of matter are interconvert into the each other, like melting or fusion. First thing is melting or fusion. The process in which the substances changes its states from solid to liquid is called melting or fusion. The temperature at which the solid starts converting into a liquid at atmospheric pressure is called melting point. Example, the melting of ice cream, you can see in the picture here. The next we have is vaporization. What is vaporization? The process in which the substances changes its state from liquid to gas. Okay, vapor is nothing but the gas. Okay, from liquid it is changing to the gas. This is called as what? Vaporization. The temperature at which the liquid starts converting into a gas at atmospheric pressure is called the boiling point. What is a boiling point? Boiling point is nothing but the temperature at which the liquid, that is the liquid, starts converting into a gaseous at atmospheric pressure is called the boiling point. Example, formation of the steam. You can see the steams on the lid of anything we have cooked. We close a lid and then we open it, and we can see that because of the steam, water droplets are formed. Okay, so this phenomena is called as what? Vaporization. Vaporization is nothing but the change from liquid to gas. Okay, it's called vapor. And the temperature at which the liquid starts changing into the gas is called as what? At atmospheric pressure is called as what? Boiling point. Third we have is freezing or solidification. The process in which the substances changes its states from liquid to solid is called as solidification or freezing. Example, formation of ice, that is from water. It will be water, and then once we are freezing it, it changes to the ice cubes. This phenomena is called as what? Freezing or solidification. Sublimation. Sublimation is the substances, a process in which the substances changes its state from solid to gas. Directly from solid it will change to gas is called as sublimation. Example, sublimation of dry ice, or we can take example of a camphor also. The camphor which used to make the pujas and all, what it does, we directly uh, give the this one, we light the camphor. The camphor directly changes from solid state to the vapor state or gaseous state. Okay, that process, so we can take an example as solid state. Okay, it without changing from the liquid, it will directly go from solid to the liquid is called as what? Sublimation. The next we have is condensation. What is condensation? The process in which the substances changes its states from gas to liquid. What is happening here? Gas to liquid, it is changing, it is called as condensation. So you can see this if you take the water droplets on the cold surface, if you take the bottle from the refrigerator, and you pour it on a glass, what happens to the outer surface of the glass? The outer surface of the glass will catch some small tiny water droplets on the cold surface. This is an example of the condensation. Condensation is the process in which the substances changes its state from gas to liquid. Is called as what? Condensation. Example, water droplets on the surface, that is cold surface. Next we have some important points here. When the temperature of the matter is increased, the kinetic energy of the particle of matter also increases. Due to the increase in kinetic energy, the particles of matter start vibrating with greater speed and move freely. Now you can remember about the water. If water once starts boiling, what will happen here? The particles present in the water starts vibrating and it starts moving very faster. Okay. When the temperature of the matter is decreased, the kinetic energy of particles of matter also decreases. Due to the decrease in kinetic energy, the particles of matter starts coming closer and developing strong intermolecular vibrations. Hence, the particles resist their motions. That is, if the temperature is very less, what will happen? Or what happened? The kinetic energy also decreases. Due to the decrease in kinetic energy, the particles of matter start coming closer. What will happen here? If there is no temperature or kinetic energy is low, what happens? The molecules will go and attach to each other with a stronger intermolecular vibration. With the help of that, what will happen? The particles restrict their motion, that is, they stand in only one place, they will not move to any other place. Okay, like the Kelvin we have, the Celsius we have, T of Kelvin, that is temperature of Kelvin, and temperature in the terms of Celsius, degree Celsius, plus 273.15. With this we have to solve the problems. Okay, next we have concept of latent heat. It is the heat required to distribute the force of attraction between the particles of matter by keeping the temperature constant. Means it is the heat, what we are giving the heat, the particles in the matter, what are the particles we have. The amount of heat energy that is required to change 1 kg of the solid into liquid at atmospheric pressure and its making melting point is known as the latent heat of fusion. Example, we have ice has a large latent temperature heat of fusion than water. The amount of heat energy that is required to change 1 mole of liquid into a gas at atmospheric pressure and its melting point is known as the latent heat of vaporization. Examples, the steam has high latent heat of vaporization than boiling water. Question, why steam causes severe burn than hot water? Answer, the steam has more heat than water. Answer here is the steam has more heat than water. This heat is called the latent heat of vaporization. This is why steam burns more than the hot water. Okay. The next part we have effect of pressure. The gases have the most space between those particles and solid have the least. So the solid and liquid are incompressible and have the negligible effect of pressure change on their changing state. That means that the gas have most space because they are having lot of space between the particles, and the solid have the least. What will happen? The solid and liquid are incompressible, so they are incompressible, we cannot compress them, whereas gas is having a lot of space between them, so we can what we can do is we can compress, or we can have a pressure or change the state of matter. When the pressure of the gas is increased, the kinetic energy of the molecule decreases, and the speed of molecules also decreases. So the molecules start coming close to each other and developing a strong force of attraction between them. The most important application of this phenomena is the formation of LPG and CNG. They are mixture of hydrocarbons and are filled in a small container at a high pressure. Next very important topic is evaporation. Evaporation is the process in which the liquid state changes to a gaseous state when it is heated at any temperature below its boiling point. Like example, we have the factors affecting. See, evaporation is nothing but what we do is the liquid, what we liquid is there, it will evaporate and change into a gaseous. Like we grow, will what we do, we dry the clothes. The clothes will be wet. Okay, after some time or after 1 hour 2 hours, what will happen, it will change, it will evaporate, the water present in the cloths get evaporated and it will get dried up. Okay, because it may be due to the temperature. Okay, and the evaporation. First point of the evaporation is surface area. The rate of evaporation increases with an increased surface of area. If so much of surface is there, if the surface is more, what will happen, the evaporation will be more. Example, we have the water on the road dries up quickly as compared to the water in the pot hole. That is, in the pot or a hole pot hole, what will happen, the water will be more there only because the surface is very small. As the road surface on the road, what will happen, it is very larger, so it will dry up very fastly. This is about first point is factors affecting evaporation, that is surface. Then second point is temperature. Increase in temperature will increase the rate of evaporation. Example, wet cloths dry quickly in hot summers than in the winter, because in hot summers will have temperature higher when compared into the winter. Third point is wind speed. The increase in wind speed will increase the rate of evaporation. For example, wet hair dries quickly when you blow dry it. Okay, we use the hair dryer. That time what happen, our hair get drier faster. Next, humidity. The increase of humidity will decrease the rate of evaporation. For example, drying your wet clothes on a hot some humid day takes a lot of time to dry than a hot dry day. That is the meaning of the humidity. If the in the surrounding, if you have the water content or humidity is more, what will happen? The rate of evaporation will decrease. Next, we have the cooling effect. That is, the particles of liquid need certain energy. What the liquid particles they need? They need some energy. So, where they will get this energy? The particles of liquid take the energy from the surrounding and make the surrounding cooler. From surrounding only they will take up the energy and they make the surrounding as cooler. Okay. This is called the cooling effect of evaporation. Cooling effect by evaporation. With the help of evaporation, what will happen? The surrounding gets cooler. Okay, this effect is called as cooling effect by evaporation. The common applications of cooling effect is perspiration. That is, because of the same reason we wear cotton clothes during summer, as cotton absorbs sweat quickly and exposes them to the atmosphere for easy evaporation. There is one more question here. Explain why does a desert cooler cool better than on a hot dry day? Reason here is the outer wall of the cooler is sprinkled by water constantly, which evaporates due to hot dry weather. This causes the cooling of air which inside the cooler. The fan sent this cool air inside the room. So in this way, what will happen? The desert cooler cools better than the hot dry days. Thanks for watching. Tune into my channel, subscribe my channel, like my channel for more videos. Thank you.